This is Vaguely Scientific. It's time to introduce the show. Now I am doing that. This is Vaguely Scientific. I am Derek. I am very happy to be here of my own volition and not under duress in any way. This is Vaguely Scientific. The scientist known as Jim is joining me. Hi, Jim. Enjoying your day?
I'm also here of my own volition, so take that for what it's worth.
This is Vaguely Scientific. We have a guest joining us as usual. Please welcome Sydney back to the show. Hello, Sydney.
Hello, hello.
Hi.
Hooray! This is the show where listeners send in questions to hear our vaguely scientific answers, and who knows, we might even get some of the answers right. But first, I think Jim has a fun science fact of the day for us. Jim?
I do. The tornado that hit Enderlin, North Dakota on June 20th, 2025 this year was the first EF5 tornado in about 12 years. Initially, it had been rated an EF3 because it moved through a sparsely populated area and didn't really have many damage indicators. However, after additional research, investigators found that it had thrown several train cars hundreds of feet, and this detail allowed scientists to get a better estimate of the strength of the tornado and upgraded it to an EF5.
I like this one because it's like a continuation of an earlier science fact where you explain to us how they rate these things.
Oh, yeah.
By kind of doing like a forensics analysis of how much damage it did.
Yeah, and there are a lot of tornadoes that are probably strong enough they could have been EF5s if they had hit something that wasn't corn.
Corn has feelings too. You don't want to damage the corn there.
Yeah, well, the corn is the natural enemy to the tornado.
That is true. I've seen those in the scholastic children's books where they teach you
and the weekly readers,
the weekly readers of the the food cycle and how tornadoes rank among corn.
Yeah, you have the earthworms, then you have the corn, then you have the tornado.
I like that this is supposed to be a science fact segment. It's great.
I mean, everything I said was factual.
Until I chimed in. Well, speaking of things that are factual, that was lazy, but I'm going to use it anyway. I think we should talk about our first question this week, which comes to us from John M. How many birds sitting on a power line would it take to cause a power outage?
What a weird question.
But I like it. I don't know.
I mean, I like it. I just think that the idea of like someone thinking about, 30,000 birds on one power line, just making it sag it doesn't have to be 30,000, but just like.
Oh, okay. I was going to say, is that your answer?
It's cartoonish.
That sounds like an answer.
Well, it's interesting because it all sort of depends on what you're looking at here, because if you are just trying to cause a power outage without making the line like sag to the ground, then realistically, this could be done with one bird.
Okay. Yeah, I have that written down.
Because basically all you have to do is cause the electricity to flow from the wire to the ground. And if you have a power pole that has enough damage to it, a bird could, cause an arc to jump from the power line to the pole and then to the ground. And so one bird could do it just all by its lonesome. It would not be a good end for that bird, but it could do it by itself.
Yeah, I looked at why birds are safe sitting on power lines to kind of expand into other topics, because you're right that you could do it very simply if you do it on purpose, or if a bird bridges to energized points or a point to the ground. And the reason birds can sit on a power line is essentially because they are not bridging the circuit to another source of power. And this took me a little bit of time to understand, so I'm also not going to explain it well. But The idea that I finally settled on is if you look at a bird sitting on two wires, there is a power imbalance. And that means that that energy is, or electricity specifically, is running through the bird, which the bird is not built to take, nor are people, by the way.
Unless it's a government drone.
Yeah, unless it's a government drone, and then that's the tell right there. Is if they're bridging two power lines, that one's not a real bird.
Mm-hmm.
So I looked at, could you run a current through birds? And why not? The answer is no. Right?
You can run a current through birds. It's just going to be very abrupt, and that'll be that.
It's just not going to live.
Yeah, can you safely run a current through birds, I suppose.
Yeah, that's a key word there.
So all the research I was doing was there were a lot of numbers. I cut all the numbers of like wattage and voltage and stuff out of my notes because I didn't feel like reading through it all. But I was reading, what is a power line connected to that the bird is not connected to, and how does that all work? How does that make the bird safe? And as long as the bird is in between 2 points where the wire is an equalized amount of energy, what is essentially happening is the bird is not creating a bridge.
Mm-hmm.
It is more creating like a side track for the energy to not necessarily go through. So if you were to take a bird perched on a power line and cut the wire in between its 2 feet, it is now the only point of access that power can go through, and that would fry the bird.
Yeah.
Right. Yeah. Because in general, from my understanding, power wants to go the shortest route possible. So the shortest route possible is going to go through the straight conduit that already exists with the bird sitting on top of it. If it went through the bird, the perfectly intact conduit line, then that's going to be a longer path. And it doesn't want to do the longer path unless it has to, like you said, because the straight path is cut.
Right.
Yeah. And also just the old adage, the path of least resistance.
Mm-hmm.
So, your power line is going to be made of copper or some other kind of metal that is really conductive. And while a bird is going to be relatively conductive, compared to glass or the air, the power line itself is much more conductive. So the electricity is going to stay in that highway instead of getting off and going through Bird Town.
Bird Town.
Man, that's a really good analogy.
Oh, man. Well, yeah, I think all this makes a lot of sense so far. I was thinking of it as what is a power outage. So, I went in that direction as opposed to, like my house here, it has, a one, the overhead lines run to it. So if that connection point goes out, then my house has a power outage, but, the whole street doesn't have a power outage. So all my mind was going there. Are we talking about, a single house power outage? Or are we talking about an entire system-wide power outage? So that was what I was contemplating as I was thinking about this question, but I didn't come to a good answer as to either way.
Well, that's really interesting because I think I love doing this when we get questions that are vague enough or general enough that we can explore different things. So the first thing I think of when somebody says power outage, I'm thinking of at least a block. However, you are correct. Just one house losing power is a power outage.
Mm-hmm.
I agree with Jim that, the minimum answer is 1. It can happen with one bird if they bridge two energy points. But another thing that can happen, even though birds are safe sitting on a power line, if there are too many birds, and you already sort of alluded to this, sagging can occur and mechanical damage can occur. So if you physically break the power line, that is also going to cause a power outage.
Yeah. Although I will say one thing I saw is that for the most part, the wire itself will not really ever be snapped by birds. But if you have an existing power pole that has damage on it already, because typically power poles are made of wood, and over years this wood can rot and it can degrade and a lot of times they try to go out of their way to replace these power poles. But if you do have a power pole that's on its last legs and enough birds are kind of on it or near it, then it can cause mechanical damage to the pole, which then would in turn, damage the line as a whole, just not the actual wire made of metal.
Well, I said I cut all the numbers out of my notes, and that was a lie. So
you cut all the voltages out of your notes.
I cut all the voltages, but here's some kilograms that I have in here. So
that's a related unit, I'm sure.
So I looked at the tensile strength of a typical messenger line.
Okay.
Usually made out of a steel core with aluminum strands, which give it support. They are designed specifically with this in mind. These lines can handle hundreds of kilograms of weight before they snap, before they break.
Mm-hmm.
I couldn't find a good answer to how much weight can they support, but a good rough estimate from what I was finding is, let's say a wire can safely support 500 kilograms.
Mm-hmm.
If each bird, and we're looking at pigeons or starlings, like small birds, they each weigh like 0.1 or 0.2 kilograms. That's some pretty simple math that if we have like 2,500 birds or more, like we could break this power line. Another thing that factors into that, the wire is going to, if the wire sags, it's going to lose stability toward the center. And if the birds are not grouped evenly, they're going to cause failure points. And it is unlikely that all of the birds are going to be equally placed if you have thousands of them. Yeah. And this is ignoring if you have bigger birds like crows and hawks. So it is theoretically possible, but that it would involve thousands of birds.
Yeah. I think one of the other things that's important to note is that there's also a big difference between the lines that sort of run through your neighborhood and the high voltage transmission lines that run cross country.
Right.
Those are going to be a lot stronger and have a higher weight threshold. And they're also going to be on those giant steel Eiffel Tower looking guys.
Right. And they're a lot higher,
they're
too.
More like collector lines.
Yeah,
for sure. Those ones are a lot higher in the air, too. So I feel like birds are less apt to perch up there. Because I think one reason I was finding that birds like to perch on power lines is like they can see the ground. And if there's like fruit or if they're looking for bugs or whatever, like they can kind of see that. But if you're, on one of those giant utility poles that are with all the really big ones, you're not going to be able to see the ground as much. Like it's not as useful of a perching spot.
Yeah.
That's a good point. Yeah, I didn't think of that. But birds don't just perch on power lines because it's fun to sit on them. They're going to be like somewhere that benefits them.
Yeah. That reminds me, I was reading a little bit about some of the other ways that birds can cause power outages.
Oh, interesting.
Because it's not just sitting on the line. And one of the ones that I thought was most interesting was the idea that sometimes a bird might build a nest in a power substation and the either falling debris from the nest or maybe like bird poop could cause a trip in the line or like an arc to occur. And typically this wouldn't be something that would hurt the bird because it would be caused by falling stuff. But depending on where they build their nest, it could in fact cause a power outage, which I thought was kind of interesting.
Oh, that makes sense. I want to revisit because there was a reason I considered chaining birds together. It was not out of maliciousness. One of the things that I was looking at in researching why birds are safe on the power line was the idea that could they cause a power outage if they just like slow down the movement of energy in some way? And that would be if they weren't, if energy were not taking the most direct path, if every bird added to the power line somehow created a longer path, which is not the case. But it made me curious. It made me curious how long of an extension cord you could have before there were a noticeable delay of any kind. And the answer to that is it really wouldn't make much of a significant difference in Earth standards, like what we could feasibly have on Earth of the length of extension cords, because the way energy works in a current is not like electrons have to move from point A to point B. It is a wave of energy. So it's almost as if once the current is connected, all of the energy throughout the whole circuit moves at the same time.
Okay.
So before any sort of delay in energy transfer ever became an issue, you'd run into something called voltage drop, which is the loss of usable voltage over long distances due to a wire's electrical resistance.
Oh, okay.
So an extension cord running a heavy appliance like a space heater can actually lose a few volts.
Mhm.
So essentially what we're talking about is we never actually notice any sort of delay in power because the cord is too long. But what we'd actually notice is if a cord is too thin or not able to carry that much energy, it wouldn't be able to provide enough power.
Oh, okay.
So that's why I was thinking if you extended the power line and somehow the birds could carry the current safely, would that cause a loss of power? And yes, but only because you couldn't do it where the birds would be safe.
Okay. Okay.
So don't try this.
Where the birds would be safe. What if you made a bunch of birds out of ballistics gel and tried it?
So they're not real birds; they're fake birds.
They're not birds. Yeah.
Yeah. Well, that's what I'm saying. We could test it out with ballistics gel.
You could create a power transformer that looks like a bird.
I'm sure someone has.
Probably. The last thing that I have in my notes on this is kind of a moot point at where we are, but when I said that as long as birds are not touching a wire and a ground or the ground, it is worth noting that while birds in the air can land on a power line and be safe as long as they're only, like, both of their feet are on the same line, you standing on the ground cannot touch that bird and be safe.
That makes sense, yeah.
Sure. Because then you're diverting the power to the ground and electricity could run through you.
Yeah, and that's where the electricity wants to go.
Right. It wants to go to the ground. Yeah.
That reminds me of another thing that I saw that is not really birds causing the outage, but sort of the direct result of there being a bird is causing the outage. And that is small predators that are able to climb up the power poles and attempt to get at the birds.
Oh.
And so predators like raccoons, for instance. I mean, maybe raccoon's a bad example. I don't know how predatory raccoons are, but I was reading small animals that
weasel, perhaps.
Yeah, maybe. But
Ox or something.
Small animals will run up the pole and they will try to go after the bird. But as soon as they bridge the gap between the pole and the wire, then there's a potential for that arc to go through them. And it's not the bird causing the power outage, but it is caused by the fact that there was a bird up on the line. So it's sort of an indirect reasoning.
It's a secondary cause.
Yeah.
Yeah, exactly.
I like that. If that's where we started with this question, is like follow-up question, how delicious do the birds look?
Are they turkeys? Are they chickens? Ducks?
A turkey on a power line would be a pretty big bird up there.
I'd be impressed if a turkey could get up to a power line.
Yeah.
Well, we have a red-tailed hawk that lives in my yard, and that's what I see perching on the power lines around here most of the time.
Well, that's pretty big too. Those are pretty big birds.
It's a pretty big bird.
Yeah. Not as big as a turkey, but big.
It's also interesting just how light birds actually are because their bones are hollow.
Yeah, they got hollow bones.
Yeah, and they have to be able to get up off the ground. So
they
don't weigh a whole lot in the first place.
What I think is interesting about bringing up a predatory animal climbing a pole is that, like, a weasel could also safely climb on a power line as long as it, like, leapt onto it. But, like, if it grabbed it with its hand before leaving whatever other support it's on, it would ground the circuit.
Yeah.
Right. Well, and also, too, I mean, circuits don't have to be completely touching. Like, depending on how high power they are and how much voltage and amperage is running through, if you're close enough, you can complete the circuit, too. So the weasel has to really jump.
That's a good point. Yeah.
One of the things that I think is really interesting that we don't really often think about is that as far as conductors and insulators go, the air is actually an insulator. And it's a good thing that it is, because if the air was not an insulator, or if the air was a worse insulator, then electrical outlets in your house would be dangerous.
Yeah, that's a good point.
But it takes quite a lot of electrical potential to actually send electricity through the air. But if you get something close enough, then it doesn't have to jump through the air anymore. It just jumps that small little gap between the air and, let's say, a bird, and then it can jump another small little gap between the bird and wherever the electricity is trying to go.
Right.
Yeah, air's a pretty good insulator, and we don't often really stop to think about how important that is to our actual electrical grid.
Yeah, we had talked about like arc cannons before. You could like ionize the air and let it take a current through it. We could all just be electric all the time.
Yeah, like static shock.
I'm not sure we would exist in our current forms if that was the case. I'm not sure.
Well, our bodies could be electric all the time. Like,
there were these things that I saw. I recently went to Niagara Falls, and they have a power plant that was built at around 1900 or so up there that they've sort of turned into a museum, and you can tour around inside of it. And one of the things I thought was really interesting was they had these 3-phase circuit breakers. And I don't really understand this super, super well, but I guess that North America's power grid runs on what's called a 3-phase thing. I'm not entirely sure what that means, but there's an A phase, a B phase, and a C phase. So each one of those lines, A, B, and C, has to have a separate breaker. And one of the things that they would do was that whenever these breakers would trip, there would be a really big explosion that would blast the doors off of these things. And basically what would happen is that they had to try to make them break very quickly. And that sort of explosion tripped the circuit so that the arc didn't pass through the air. And I think that it was something like 0.03 of a second to basically blast this thing open to make sure that it didn't cause a huge surge. So I thought that was kind of neat, and it just reminded me, talking about like air being a really good insulator, that they were able to do that and do it fast to make sure that the electricity did not surge across the entire power grid.
That probably would have been bad.
Probably, especially in 1900, everything would be on fire.
Well, you figure not as many people had electricity in their homes in 1900, so maybe it would be okay because it would just damage some people's homes, not everyone's.
Well, it would just be that one guy down on East Street got all 67 million volts directly into their house.
Yeah.
It would have been worse for one person.
Yeah. You know what came up a lot, though, actually, that birds do? Birds poop a lot.
Yeah.
I don't know if you've noticed this.
Oh, they do.
Yes.
But birds have a digestive system. And
what?
Apparently, one of the things that they can do is that bird poop can get sort of up underneath the little insulator holder thingies, and that can cause an arc because the insulator is basically designed to keep the wire from, reaching ground. And I don't know what insulators are made of now. I know they used to be made of glass. I feel like they were maybe they're made of ceramic now, or they were made of ceramic for a while. But at any rate, the bird poop can get in there and it can complete a circuit basically, and cause that to arc as well.
So what I keep hearing is that the answer to this question is either 1 or negligible.
25,000.
Yeah, like depending on the specifics of the question.
Yeah. I think it's just so fascinating how we have a very robust power grid, especially just like in the United States, our power grid is very robust, but it has the weirdest vulnerabilities.
Bird poop.
Like trees and small animals and bird poop. Yeah.
It's really hard to account for every possible scenario in nature.
Yeah. And one of the things that I was researching was the idea that, it might be a good idea if we could just get our power grid and kind of move it underground instead of having all these wires and power poles out on the road, kind of bury it like you would phone lines or TV lines or, sewer or whatever. And one of the counter arguments to that is that it would become extremely difficult to service.
Yeah.
And
generally,
you don't have to service things like phone lines all that often. You don't have to service things like the sewer all that often. But power lines kind of need to be inspected pretty regularly to make sure that they're doing what they need to do and there's no shorts and things like that. So realistically, it would just be more trouble than it's worth.
I mean, especially if it were in like a city scenario, because then they would have to run under roads, which we would then have to close down and tear up.
Mm-hmm.
So yeah, it'd be hard to get to.
I mean, there are definitely places, though, that do have most of their grid underground. Mm-hmm. Like, that's definitely a thing.
Yeah.
Mm-hmm.
It's doable.
It looks nicer.
It does, yeah.
Yeah. Actually, I think that in a lot of cities that is buried underground, but sort of in the middle of a downtown region, there's a lot more underground infrastructure to begin with.
Yeah.
And so servicing it isn't as big of a deal.
There are like service hatches to get into like sewer systems and stuff like that. So yeah.
Yeah.
Well, and even like skyscrapers, think about how many floors go down underneath the skyscraper anyway, just for stability's sake. So like those lower floors, you can have pipes and conduit and things like that are still underground, but easily accessible by humans.
Yeah.
You know what? My mind has changed. Let's move all of our power lines underground.
Do it.
Yeah, but then where are the birds going to sit?
On trees.
On trees like they're supposed to. We could have more room for trees.
That's true. I think it's interesting how power poles themselves as a technology have changed very little over the last 100 and some years. You would think that there would be small improvements you could do to them to prevent these kinds of accidents from happening. But as far as things go, there's not much you can do to account. It's kind of like you said, you can't account for every little thing that's going to happen.
Yeah. And that's why, I mean, the way you phrased, we can't prevent small animals or stuff from like damaging this stuff. It's interesting that seems like a mundane problem because it's a known entity, but the idea that we can't stop it just kind of goes to show how chaotic nature is versus how much we've tried to order our infrastructure.
Right.
Sure.
Well, listeners, this is our public service announcement. Please do not go to try to touch the birds on the power lines. It's a bad idea. In the meantime, a more informative question, or a more productive question, I suppose. Question 2 this week is, can we make honey without bees? And I looked into this a long time ago, and I feel like I found more information now that maybe didn't exist back then. I don't know.
Yeah, I think that's true because apparently the answer to this is yes.
Right.
Yeah.
But from what I was reading, it's a fairly recent development. So, I mean, if you looked at this like 5-6 years ago, I think the answer might have been no at the time.
Yeah, I think that is actually the case.
Mm-hmm.
We do now have synthetic lab-made honey, which they replicate what honey is chemically without involving bees. And I find that interesting because I was reading a lot of references to vegans who wanted a vegan-friendly solution to honey. And I always find that fascinating because I had a friend who was a vegan when I was very young who kind of taught me what veganism is. And I would always ask questions like, well, why don't you... What about wool? Why are you against wool? Because they don't, kill the sheep. And he didn't like wool because it was cruelty to animals. It was how the animals were treated. So like things like dairy, like milk, I would always be like, well, milk doesn't hurt the cow. And he's like, yeah, but they don't treat the cows well. And at one point I was like, well, what about honey? Because honey comes from bees. And he had no problem with honey. And he claimed that honey production is not harmful to bees. And I have now known other research to show that a lot of vegans are against honey. The cruelty-free kind of vegan, not the health kind of vegan.
Right. I always thought that was kind of interesting because there are a lot of examples of animals where the animal products are not necessarily hurting the animal, but with things like sheep, I could see the argument being made for how they're treated just in captivity, basically. But one of the things I thought was most interesting about this, so the main one that I found was there was a company called Melabio. I think that's how you say it.
I saw that one, yeah.
Yeah, and they've been working on making a synthetic honey for a while, specifically because I think one of the founders is vegan and kind of just missed honey because they hadn't always been vegan.
Yeah.
And the way that it works is really, really simple, actually. They use yeast to process the sugars in basically the same way that a lot of the bee enzymes do when they store honey in the cylinders and because bees go around, they collect the nectar and the pollen and they throw it up, and all the enzymes that kind of come along with that turn it into honey. But the yeast fermentation, and they call it fermentation because it's a very similar process to brewing alcohol. But the yeast fermentation sort of goes through and does a lot of the same kinds of stuff, and they end up with a honey. And I think that is fascinating because it's very similar in a lot of ways to how they make insulin. Because insulin also uses yeast and other bacteria to go through the chemical processes to take one thing and turn it into something else.
That I did not know that. That's cool.
The connection with insulin is super interesting. Yeah, I had no idea how they made insulin. Yeah, I also was finding articles about the Melabio or Melobio, however you say it. And it seems like they were looking to get their product out 2021, but it didn't seem like there's a lot of the product out in the market, which makes me think that maybe it wasn't actually as successful as they were thinking it would be, whether it's because it's taste different or it's just a longer process and then it's cost prohibitive. I'm not sure. I didn't find enough research on that end, but I think it seems like, yes, technically this is possible to make honey without bees, but I don't think we have quite yet reached the point where we can easily and successfully replicate making honey without bees. Something about the enzymes in the bee stomachs and then the regurgitation to the other bee stomachs, to the regurgitation into the little honeycomb, to the flapping with the wings. We've gotten pretty close to figuring it out. Yeah. We haven't completely figured out how to do the whole process yet. And I think that's, I don't know, there's something kind of beautiful about nature just being nature, you know?
Another element to that, though, why it may not have been successful, and this is some speculation based on a little bit of information that I have. If you go to the store to buy honey, there is a significant amount of brands of honey or generic honeys out there that if you buy, you may not be buying real honey. You may be buying what is essentially syrup. That is made of like cooked fruit and or cooked flowers. And this is similar to using corn syrup instead of sugar. There's not really a reason to want honey over that for the flavor for most people, but honey has enzymes like glucose and oxidase and antibacterial properties, whereas this kind of thing doesn't. So I am someone who enjoys having honey on hand because I find that it helps with allergies. But I have to make sure that I get real honey, specifically local honey, or else it really doesn't do anything. I'm just eating a sweet syrup flavor thing. So they're marketed as honey, but they're
interesting.
Yeah, I would say honey. It would. I can't think of specifically what words would be on there, but like they do have to write the ingredients. Obviously, they're required by law, so you can easily look at the label to find out if it is real honey, and it will be on the shelf right next to the real honey. Real honey tends to be more expensive. That would be the first thing to look for.
There used to be a vegan honey, and it was like honey, Honee, and it was exactly what you're talking about, Derek. It was basically. It was a syrup made out of like apples with like flour augment to it. So it was like a sticky syrup, but it tasted a little more like honey. But apparently it's more widespread than I thought.
Flavored syrup.
Yeah.
Well, I'm wondering if that contributed to the lab made honey not being as successful, because to the layman, to somebody who's just going to the grocery store and like, oh, I want honey for my for my toast or whatever you put honey on it. What do people put honey on? I don't know. Listeners, let me know. I put it in tea.
In tea.
Yeah. I wonder how many people were looking at saying, oh, this is lab-made honey versus, oh, this is just the inexpensive honey, quote unquote, honey that I always get.
Mm-hmm.
So cost probably has something to do with it.
Yeah. Well, one of the articles I was reading kind of outright said that it's something that hasn't really ever been done on a large scale, or now that it has been done, it hasn't really caught on, just because natural honey is a lot cheaper than lab-made honey. And it's the same kind of thing that we see now that we have prototypes of lab-grown meat. And
oh, right.
If you compare the price of lab-grown meat to just natural beef, even though you're still going through the whole process of, raising a cow and then slaughtering it, I mean, you're still doing this on such a massive scale that the cost is much lower than the lab-grown beef. Yeah. And there are a lot of things that they're working on to try to get that cost down. And I imagine that it's probably going to be the same with things like honey as well. Mm-hmm. But it's sort of just cost prohibitive right now. So the only people who are really going to maybe go after this are the type of people who just can't eat natural honey, whether it's by a choice or a dietary reason. And so that's going to be, I think, a limiting factor until they can bring the cost of the process down fairly low.
Yeah.
Right.
So I looked into two other avenues here a long time ago, and I believe it was on an April Fool's episode that may or may not exist, because we never did an April Fool's episode. But at one point, we were asked the question, what would human beings need to eat in order to vomit honey? And we all jokingly said, honey. That is the answer right. to that question. And that still truly is the answer to that question. But it has always been on my mind. And I'm glad that we're finally talking about this question that could we make honey without bees? Could humans actually make honey in their own stomachs? No. But I wanted to bring up the fact that while we do use the term regurgitate and we do keep saying honey is bee vomit, honey is actually not vomit because it is not digested, and it is intended to be stored in a honey stomach or a crop, not a digestive stomach, and passed and processed. So that is the main reason that humans couldn't do that in their stomachs, is that our stomachs would dissolve and break down anything we put in there to be ingredients for honey.
We have one stomach, not two.
Yeah.
We only have the one. We do not have the honey crops, which is interesting because I also compared that to birds. As we all know, birds, a lot of birds anyway, feed their young by chewing up, eating, I guess not chewing, but the mother bird will eat and then regurgitate into the hatchling's mouth. And that is regurgitation because the mother bird will start digesting the food for the young. So it is not in an effort to create a new byproduct. It is literally just to digest the food. Mm-hmm. Lastly, I looked at I don't know if this is a cop-out answer to the question or if it is just a different avenue of answering it, but I looked up, do other animals aside from bees make honey that we could harvest? And I found a few. So there are some species of wasp that also make honey in much the same way, and we tend to not harvest it, even though it is technically edible by humans. It's the difficulty and danger of keeping wasps is why it would be kind of rare and hard to do. And there are things called stingless bees. The fact that they are called bees maybe kind of discounts them, but they're not related to honeybees, or at least not directly. And then there's also a type of ant called a honeypot ant, or just a honey ant. And they also create a thick, syrupy, floral honey that tastes very similar to honeybee honey. And they, I guess, tend to live in Australia, is what I'm reading here.
Oh, interesting.
So that the last point I wanted to make is obviously the thing I noticed is these are all insects.
Mm-hmm.
Mm-hmm.
And so I was like, well, why is it that only insects create honey? And I found something kind of interesting. Species like bees and ants and wasps are something called eusocial, EUSOCIAL, which means they live in large colonies and they share food and labor. So they collect and store resources, which most animals don't do. Like humans do that on some scale. But most animals, the closest thing I can think of is squirrels burying acorns for winter. But that's not really creating a storehouse. That's just putting things aside to eat them later. Whereas this is a community. This is a thing that creates like a class of food foragers and stuff.
Mm.
And that really kind of only exists in insects. And the other aspect of that is insects, unlike even hummingbirds, specifically have organs that can hold and store nectar, whereas most animals don't eat just nectar. Even something like a hummingbird, when it eats the nectar, it's not storing it, it's digesting it immediately.
Right, yeah.
I found that very interesting.
Yeah, no, it's super, super interesting that you talk about the communal nature of the bees or insects in general, because my boss, he has a couple beehives and he always talks about them as hives. And the way he's explained it to me is that, yes, you have individual bees, but bees are this entity that is a community entity and they exist in the hive. So it doesn't really matter how many individual bees you have. What matters is how many hives you have, because it's all like one larger system. It's something that is hard to understand from, like, if you're thinking about a mammal's perspective, because like mammals exist as individuals, but bees are so honeybees specifically are so reliant on their fellow workers and their queens and everyone in that entity, in that hive, working together to create the food, to create the systems that they need, that it almost, the individual is unimportant. It is only the entity that is the hive.
Yeah.
And we really only see that type of social structure in ants, which bees are more closely related to ants than they are to like other sorts of insects.
You know, we think about bees and we think about honeybees, but ultimately honeybees are a domesticated creature. Like, when we're talking about native bees, there's all kinds of native bees, and yes, some of them do make honey, but most native bees are solitary creatures. Most native bees burrow, and they don't exist in these large colonies that we've created with the honeybee. You know, we've over years and millennia have come to acknowledge, honey is a useful agricultural purpose, so we're going to refine it, we're going to farm it, we're going to keep making the bees more and more docile so that we can farm it, and so we as humans have had somewhat of a role in forming the honeybee being this collective social entity, because we've wanted their resource, which is honey. So I think that's also a really interesting element of bee culture.
Yeah, that makes sense, because it's not only that we want their resource, but they also do a lot to like pollinate our crops. So it's not just that we want their honey, but we also want to keep them around to be part of the agricultural system of ours. So
yeah, absolutely.
Yeah. I also think it's interesting to note that when it comes to making honey, bees go around and they gather tiny amounts of nectar and they bring that back. And so that's also something that I think is a limiting factor for artificial honey. Because, I mean, we're not going to be going around and gathering up nectar from flowers to make artificial honey. We're going to be starting with a base sugar that is probably chemically distinct. And it always kind of reminds me, there was a news article several years back where there was a beehive that was making blue honey. And they were like, why is the honey blue? What's going on here? And it turns out that they had found, the bees had found this big bag of blue M&Ms that had been thrown in a dumpster. And they were taking the sugar from the blue M&Ms and bringing it back to their hive, and the artificial coloring came with it. And so that makes me think about how honey is going to be a an amalgam of all of the different types of flavors and varieties of nectar. And maybe that's not something, because to be fair, I don't really eat honey. I don't like it that much, but it might be one of those things where maybe there's a noticeable difference in taste between honey that is sourced from a wide variety of wildflowers versus just artificial lab-grown honey. I know that's something that we see with artificial meat.
Right. No, I can't say to that, I haven't had the artificial honey, but there's different types of honey depending on the seasonality and depending on the region you're in. So the most common type of honey when you're in the store is known as clover honey, because, think about a clover flower, that you see in your yard, little tiny white flowers. They're everywhere. It's really easy. That's like the most common, most benign tasting, I guess, of honeys. And then orange blossom is another one that's really popular on a commercial scale. But something that's come up in our region recently is the spot-on lanternfly, right? You're familiar with the spot-on lanternfly. Spot-on lanternflies excrete a sticky substance known as honeydew. And it's very sticky and it's very sweet and it has a lot of sugars in it. So what bees in our area have been doing, honeybees in our area, is that they've been picking up the excreted honeydew from the spot-on lanternfly and taking it back, treating it as if it is a nectar. And then that that honeydew is used to create bee honey. And I had some recently. Again, my boss is keeps bees, so he gave some to me, and it tastes so different and it looks different too. It's like stickier looking, and it moves, like the viscosity is different. It doesn't crystallize as fast. It stays in its honey form for longer, and it has it's a weird aftertaste. I can't quite describe it, but it definitely tastes different than the usual honey you get around here. Very interesting.
I have met my fair share of apiarists in my life, and I am tangentially connected to people who work at Renaissance fairs, and honey is a very common thing that is sold at Renaissance fairs. I'm always curious to know how they make sure each hive is only getting primarily that kind of nectar. And sure, it depends on where the bee boxes are set and stuff, but they're very meticulous about this is this kind of honey. It comes from these kinds of flowers or these kinds of plants. And that's why I mentioned earlier, honey is good for if you are someone who has allergies, specifically if you use local honey, because it builds up your tolerance to the pollen that will be in the area that you're in. So if you're, I don't know how vast of a difference it makes, but if you are always eating imported honey and you're building up a tolerance to this pollen you're never experiencing. But clover honey is very common in northeastern United States, which is where we are. So local clover honey is generally the most helpful thing for me, at least.
Yeah.
Yeah.
But yeah, honey's great, even if Jim doesn't like it.
I mean, I also am not a huge honey eater, but I think it's fascinating.
Yeah, I think that the whole process is neat, and I really love that we are apparently able to do this now.
Yeah.
And one of the other things I was reading about was other stuff that they want to make using this genetically modified yeast. And so one of the other ones that came up was egg whites. And I thought that was super interesting because egg whites are just completely chemically unrelated to honey, in every possible way I can think of.
Huh.
Oh, and milk. That was the other one. Yeah, so egg whites and milk. So some dairy stuff using yeast. And I mean, I totally believe they can do it. I don't see any reason why that would be impossible, because really what you can do with yeast and what you can do with a lot of bacteria is you can just insert genes that make certain things, and the yeast or the bacteria will just sort of run those genes like a software program, and they will create whatever byproduct, which is exactly how the insulin thing works. But
yeah,
I just think it's fascinating that we are getting close to, or at a point where we can actually go out and make things that come from animals out of yeast, or not out of yeast, but like we can make the yeast make it for us. I think that is
Right.
so interesting. It's like alchemy.
Yeah, it is. It is a little bit of alchemy.
Well, alchemy is just chemistry. It didn't go
Yeah.
away.
No, it's magic chemistry,
It's
though.
magic chemistry that they just got things wrong. That's what it is.
Yeah, it's like we didn't understand chemistry fully, so we create magic in the form of alchemy.
Yeah.
So what you're saying is that instead of using chemistry for their alchemy, what they should have been using was biology for their alchemy.
I mean, that's what they were doing. They were making liquid gold, right? That's honey. Right there.
That's urine.
That's true. That's true.
I think it's oil. No, that's black gold.
That's black gold.
Oh, that's Texas tea.
That's Texas tea. Yeah, they make a Texas. And they were putting honey in their Texas tea.
They were putting their liquid gold in their black gold. And
Yeah.
there you go.
I don't think they should have done
They
that.
should have done that. That was a mistake that they made, and that's why alchemy isn't around anymore.
I can't think of a worse possible thing you could do with honey and oil. Because A, you're ruining your honey, and B, I imagine you're also ruining your oil. Like getting the honey back out of the oil is not going to be easy.
Two really sticky substances, combining them together. What could go wrong?
Yeah, although maybe they're not really soluble with one another because
maybe.
Well, crude oil has so many things in it that it's really just hard to say, but they may not mix super well. I don't know.
Well, it's hard to say on air because of how crude it is. You're right. Bad joke. It's a bad joke.
Grumble.
Oh,
but I'll be interested in seeing what other kind of things come out of the processes they're doing with yeast, because and especially where things like lab grown meat are concerned as well, because I think these are things that are still really in their infancy.
Yeah.
But if you had asked me 15 years ago, oh, someday, do you think they're going to grow lab grown meat? And I'll be like, yeah, maybe in 100 years.
Right.
When we hit like Star Trek times, then maybe, yeah. And it's like happening. I'm in my 30s still.
The most personally fascinating part of this question, and I don't know how much this will mean to the listeners, but to me, since we got this question submitted, and now, in between that span, the answer to the question has changed. That's how recent this technology is.
That's true. Good point.
Yeah.
It's also a function of how long we've been doing this show.
8 years? That's not that long. What?
I mean, I guess not, but like it's just fascinating that we have had a long enough run that we can look at a question that seemed like science fiction, and now it's just happening.
Yeah, that's true.
And I also feel like with the door open on this kind of stuff, it's not just going to be honey and egg whites and things like that. I think we're going to see eventually that we are able to create a wide variety of animal products using things like yeast. And I don't know what the price is going to look like on those kinds of things, because again, these are going to be very small batch.
Yeah.
And so they're not going to be mass produced. But I mean, in the future, and you know what? This is sort of like the first step to replicators.
Yeah, a little bit.
Good point.
Yeah.
It actually reminds me a lot of, in The Expanse, they have these things called recyclers. And a lot of the stuff that is in The Expanse that is intended to be disposed of. So food waste, obviously, but also a lot of like their containers, like storage containers, are made out of a biological, I can't remember exactly what it's supposed to be like. It's like a bioplastic. So probably like a resin-ish kind of thing, but they throw everything in the recycler and then it makes new stuff that can be, printed out or whatever. And really all the recycler is in The Expanse is just a mushroom farm, just extremely technological and fancy and futuristic. And yeast is just a fungus. So we're like getting there.
Yeah.
I want to make a bingo card for the listeners to print out, and it'll have things on it like Gundam and The Expanse and the
Doctor Who
and Doctor Who and the various mass extinctions. Yeah. All the things what will Jim bring up this episode?
Yeah.
I am curious though about the nutritional like how the honey made without bees, how that compares nutritionally to honey made with bees.
I was reading that the studies were showing it had comparable antibacterial qualities and comparable like enzymes like probiotics and stuff. Are probiotics enzymes? I don't know.
Mm.
So what I was reading about it, because they compared that to the corn syrup, like commercially available generic honey, mock honey, which does not really have any of the health benefits. It's pretty much just flavor. So the effort was made to make it as healthy as actual honey.
I wonder
that's cool.
too if it lasts forever. You know, like
Right.
the old adage that honey was found in the Egyptian tombs and you could still eat it. You know, it
And it doesn't
crystallizes, but
expire.
you can uncrystallize it. Yeah, I wonder if this new, lab honey, for lack of a better word, if it'll have that same property. I wonder. Yeah.
Honestly, just to wrap it up, I think it would be really interesting to see the sequence of chemical reactions that have to happen to make honey. Because in my head, honey is a very complicated thing.
Sure.
Because it's in my head, and maybe this is not true in real life, but I feel like honey is not just like one thing. It's not like, here's the honey molecule. No, it's like a mixture of stuff, isn't it?
Well, I mean, yeah, because it is. I mean, a lot of the problem was what is actually inside the bee's body that is altering the nectar and the sugars. So there's a lot that goes into it. Is honey like itself just a compound? I don't actually know. That's cool though. That's a cool thought.
Well, I guess I better go try some honey now.
Go try some honey. Teaspoon of honey for if you have a cold coming on, should help your throat, I suppose. I don't know.
I kind of want to try a bunch of different honeys now because I've really only ever had the store-bought. It probably wasn't even real honey now that I know that's a thing.
Yeah, the honey bear one, the one in the little bear shape, that one.
Yeah.
Yeah.
I'm sure I have an assortment of honeys that you can sample here.
I'll bring my popsicle stick.
Well, listeners, this week, what I want you to let us know is this is what you meant when you asked us to explain the birds and the bees, right?
No way. Wow.
If you have any thoughts on that or any of the actual things we talked about in this episode, you can email us at feedback@vaguelyscientific.com, or you can comment on the blog on the website, you can like us on Facebook, or you can follow us on Blue Sky @vaguelyscientific. Jim, where do we get all these wacky questions?
We get them from you, the listeners. And if you have a question that needs to be answered in a vaguely scientific manner, please email us at questions@vaguelyscientific.com. If you want to get our episodes the minute that they're released, you can subscribe to our podcast on Apple Podcasts, YouTube, Spotify, and all the other cool places that podcasts like to hang out. And don't forget that subscribing and leaving feedback really helps us out, and so does telling your friends.
Tell all your friends.
Our vaguely musical intro is composed by Anthony Pizzelli, and check out our merch store over at vaguelyscientific.threadless.com. There are so many cool things there. Nothing with a B on it yet, though. Maybe
Darn.
we should
No, not
make
yet.
a B.
We'll get on that.
Make a beeline for making those products.
Whoa. Well, despite that, thank you to Sydney. I'm sorry, that was rude. Well, thank you to Sydney for being our guest this week.
Sure thing. I'll keep my puns to myself.
For Vaguely Scientific, I am Derek.
I'm Jim.
And I'm Sydney.
And just a reminder that there are no secret messages hidden in the past several episodes.
Oh, that's good. Well, toodaloo then. I like in my notes, I have, if a bird happens to create an arc that travels through their body, it can cause an outage. And then I have a little subnote, big birds are better at this.
Big birds are better at this. It will cause a significant outage in itself.
Yes.
Yeah. Oh,
All right.
poor birds.